students, today we'll learn the chapter number 6 of class 8 science, that is combustion and flame. Combustion means a chemical process where the substance reacts with oxygen to produce heat. So what is combustion? Combustion is a chemical process. That means the chemical reaction where some substances are there, some amount of oxygen is there, and in the presence of oxygen the substances catch fire. That means nothing but oxidation. The substances which catches fire or reacts with the oxygen to produce heat are known as fuel or combustible substances. So what are the three different things required for burning a fuel? Fuel is required. Here the fuel is the candle, and oxygen is required. That is from the atmosphere we get the oxygen. Another is minimum heat is required. That is the ignition temperature. This experiment will show how oxygen is important for burning. In the first one, you can find that on a floor there are certain wood pieces, and on that wood pieces there is a glass tumbler or chimney, and in these three cases the candle is burning in the first instance, but after 1 or 2 minutes you can see that the third one where the tumbler is covered with a glass or metal, it ceases to burn. That means it no longer gives any flame. You can see. That means here what happened? It couldn't get the oxygen as it is covered with the lid. And in the second one, see, the second one has chimney, but it is open only to the top, not to the bottom. So what happens in your classroom also? You can see that if two windows are on the one is on the left side, another is the right side, then you can say that is there the wind is blowing rapidly. But if you can find a classroom where only one window is there on the left side and on the right side there are no, then you can't feel this type of the rapid flow of wind. So in the second case you can find the tumbler is covered one side on the bottom side and open at the top side. So air may come into that tumbler but it may not blow, so sufficient oxygen may not be provided to that candle. So the candle will run or glow for few minutes, then you can find the candle will stop glowing. And in case of the first one, you can find there is space at the bottom and there is open space at the top. So there is ample chance of wind to blow. So the candle continues to burn up to last. That means sufficient supply of oxygen is required to the fuel for burning. This is wood and this is coal. This is LPG cylinder, and the final one is that is the kerosene lamp. And you can find this wood are solid, that coal is also solid, but LPG gas, this is a gas and this is also liquid. Why? Liquefied petroleum gas. Actually this is the gas and it has been liquefied under pressure. And another is kerosene, petrol, diesel, all these are liquid fuels. So we can divide the fuels into solid fuels, liquid fuels and gaseous fuels. So we can convert the fuels into solid, liquid and gaseous. This wood, apple and this coal are the solid fuels, and the diesel, petrol, kerosene used in vehicles for use in lamps are the liquid fuels, and the gaseous fuels include LPG and CNG. CNG is a clear fuel which can be used to reduce the pollution in metros. For a candle to burn, it requires the minimum temperature, that is known as ignition temperature. We have to apply heat to reach its ignition temperature. Once it reaches the ignition temperature, it catches fire. Different objects have different ignition temperature. That candle may easily catch fire, but the paper may easily catch fire. Petrol, diesel, all these have very less ignition temperature. But if you think of different objects, like a log of wood has more ignition temperature than petrol, diesel, etc. Flame is the raised volatile portion of the burning or combustible substance. Flame. This is flame. This is the wax candle, and you can see the volatile portion of the wax candle that creates a flame. That is the reddish in color. But if you see the flame, the closer view will show that the innermost black portion, the middle one is the yellow portion, and the outermost reddish and blue color you can find, out of which the innermost part, which is black in color, actually it is the unburnt carbon particles, and it creates very less heat, that means negligible heat. And the middle part, that is yellowish in color, that is actually moderately or partially combustion occurs, so the heat evaporates it in this portion is moderate, actually, that is not very high, not very low. And the outermost zone, you can see the blue flame. You can see in case of your gas burners, the color is blue in blue. When the gas is about to be completed, you can see the reddish color. That means the blue color is the hottest part of the flame. That if you check with a thermometer, you can find that the highest heat can be checked at the outermost region, and the lowest heat you can find in case of the black tip of the burning wick. And not necessarily all the substances which are combustible, or otherwise we call them as fuel, may create the flame. Some substances may not create the flame. Those substances which are not rich in water vapor or any other gas, they may not show the flame. So these are various regions of the flame. That is the least hot black flame, and the moderately hot the yellowish portion, and the hottest part, that is the outermost part, bluish in color. You may see the coal with good quality, that means it has less water vapor content, then you can't find the flame, because the charcoal and coal have less impurities. If there is less gaseous impurities, there may not be any volatile substances, you can't find any flame. What is actually charcoal? Char means after burning. That means the coal has been burnt, so that the volatile materials, that is the water vapor, already has been evolved from this, so only the pure carbon is left. That's why this is known as charcoal. Charcoal gives more heat than others, because there is no other volatile materials present here. You know, mastics are nowadays very much important for us. Without mastics, we can't burn the gas. Without mastic, we can't burn a candle. So, if we are going for a picnic also, we can take the mastics, the box of mastic in our pocket also. These are known as safety mastics. But in earlier days, the people were using the stones. Two stones are rubbed with each other to create a light. Then what happened? They tried a pine wood. Pine wood, do you know that pine wood is very light, and when it is dipped in sulfur, eventually it catches fire. Then the second generation, they are antimony trisulfide, potassium chlorate, white phosphorus, glue and starch are taken together, and a mixture is created. That mixture is pasted on the top of a pine wood, and whenever any requirement of combustion occurs, so we have to rub this glue along with that mastic with a rough surface. But what happened? It has some demerits. White phosphorus catches fire eventually. So what happens? This is not safe at all. It may catch fire anytime. So we changed the white phosphorus to red phosphorus. Red phosphorus is safe because it doesn't catch fire spontaneously. When red phosphorus is changed to white phosphorus only, it catches fire. So nowadays safety match have only antimony trisulfide, potassium chlorate are put separate on the tip of the mastic, and the red phosphorus itself is pasted on the cover of the mastic along with some powder glass to make it rough. So we have to connect and rub the mastic on the cover of the mastics. Then only after rubbing, some of the red phosphorus will be converted into white phosphorus. Red phosphorus doesn't catch fire eventually, but white phosphorus will catch fire. Then what happened? After rubbing only we can get the fire. So these are safe until we are rubbing the mastics with the cover. Combustion can be further divided into rapid, spontaneous and explosion. Rapid means that is LPG ones or wood ones. It gives enormous amount of heat and light. Spontaneous means somehow you can see in case of mastics, phosphorus catches fire spontaneously without any effort, means no heat is given to that phosphorus, but it may take or catch the fire easily in room temperature. And explosion in case of cracker, when these catches fire, enormous amount of light, heat and sound are produced within a limited period. Within 1 or 2 seconds you can find the whole bomb or cracker can be exploded, and enormous sound and light and heat is released. Sometimes these explosions are very dangerous. These can create loss to the properties. The fire is important for our life, but sometimes fire creates problems. If it catches in petrol pumps, or our houses catches fire, or in schools, buildings, if it catches fire, fire is hazardous for us. So in this time we should be ready to extinguish the fire. So there are 3 methods you can extinguish the fire. What are required for a fire to burn? First one is the fuel, second one is the sufficient supply of oxygen, and third one is the ignition temperature. So in order to extinguish the fire, we have to remove either one of these 3. First one, so apply water on the fuel. So what will happen? Water will decrease the temperature, so it will not attain the ignition temperature, and the fire will cease to make flame. And another important factor is there. When water will be applied on the fuel, that is the burning fuel, water will be converted into water vapors. These water vapors will detach the oxygen from the fuel. So 2 methods are involved in extinguishing the fire by applying water. Another point is there. This is the fire extinguisher, and here you can find there are 2 chemicals. The powder sodium bicarbonate, that is the baking soda, or potassium bicarbonate, may be in the powder form, and another container will contain certain amount of acid, that is hydrochloric acid. So what happens at the time of to extinguish the fire, we have to press it, so the hydrochloric acid which was in the container, that is a very thin glass container, that will break, and finally it will mixes with the sodium bicarbonate or potassium bicarbonate, and release enormous amount of carbon dioxide. So carbon dioxide is heavier than the oxygen, so carbon dioxide will make a blanket over the fuel and it will separate the oxygen from the fuel. In this process, that fuel will not get sufficient amount of oxygen and the fire will be extinguished. Another method, when petrol, diesel, etc. catches fire, we may apply some foam over this, so the foam will make a blanket over the fuel and it will make the fuel separate from the supply of oxygen, so the fuel may not get sufficient amount of oxygen for combustion and stops to burn. A large number of combustible substances are there, but all these may not be treated as good fuels. A good fuels have certain qualities. First one, it should be cheap. Second one, it should be readily available. Third one, it should burn easily at a moderate rate. Don't create poisonous gases. Don't leave behind any undesirable substances, or don't leave behind more ash, or it should have good calorific value. What is calorific value? Calorific value is the value or the amount of heat produced by complete combustion of 1 kg fuel. It is expressed, the fuel efficiency is expressed in the terms of calorific value, and the unit of calorific value is kilojoule per kg. Joule, as you know, joule is the unit of work. Here heat is energy, energy is the maximum work done, so heat energy may be expressed in terms of joule, and kilojoules means 1000 joule makes a kilojoule per kg. That means when 1 kg fuel is burnt, that is complete combustion occurs, then whatever amount of heat we get, we will calculate it in terms of kilojoule, and that will be expressed in terms of kilojoule per kg. That will be identified as its calorific value. Which are the calorific values of some fuels? We may use these fuels: cow dung cake, wood, coal. That is, cow dung cake and wood have very less calorific value. Also, it may be used in domestic purposes. It may not be used in industrial purposes. But coal, petrol, kerosene, diesel, these may be used in both in domestic purposes and in industrial purposes. At its calorific value, the calorific value of these fuels are moderate. Hydrogen has highest calorific value, but it can't be used as a fuel. Although combustion is necessary, it is also an evil. When combustion occurs, there are certain shortcomings are there, or the consequences are there, which are not good for the environment. First one is, for combustion we use a large amount of wood and fuel, so deforestation occurs. When deforestation occurs, its consequences are the low rainfall, or that is increase in the level of carbon dioxide. All these are, when the level of carbon dioxide will be increased, it causes global warming. What is global warming? Carbon dioxide, other gases like methane, sulfur dioxide, all these are very much capable of keeping the temperature. You know, at the daytime our the temperature of the atmosphere increases, and at the night the temperature decreases. And at the night, what happens? Some amount of heat is captured by this carbon dioxide. Although this is very much important, as it works like a blanket. Otherwise, what would happen? The temperature may go on up to minus 10 degree, 20 degree like this. So carbon dioxide is necessary, But what happens? Enormous amount of carbon dioxide, more amount of carbon dioxide increases the temperature. The increase in the temperature, that is the average temperature of the earth. Average temperature means somehow in summer 5 degree more, in winter also 5 degree more. That is known as increase in the average temperature. When the average temperature will be increased, it causes global warming. Do you know that due to global warming, the 2 or 3% of the total water which is polarized as a glacier in the North Pole and the South Pole may start melt and that will increase the sea level. So you know that most of the cities, townships have been grown near the seashores, and when the level of sea will increase, the civilization will go deep under the sea level. Now this is acid rain. What happens? Sulfur dioxide, carbon dioxide or nitrous oxide, these when mixed with the rainwater creates certain acids, sulfuric acid and nitric acid, and these acids when fall on the plants or animals, it may cause different skin diseases. On the plants you can see the picture, the plants may be weathered out due to these acids, and the acidity level of the soil also increase, that will act adversely on the plantation. Thank you.